Hello everybody, I'm back. Last time we were working on adding this new gravity clone type of clone, and I think that I was working on editing this to be specific to the linear type of clone. So I'll call this linear clone, create linear clone, because it's moving linearly from the source to the target. So we'll say OK, and then animation type I'll set to linear. So we have two animation types, gravity and linear. And just to make it clearer that they're special, I will make them all capital letters. Now, here in the draw event, where we are, So here in the draw event, where we're only doing a linear transition right now, we'll need to have if statement that says if, and then we'll want to say if the animation type is equal to linear, then we'll do all of this stuff. Otherwise, the animation type might be gravity, and we'll do something else. So the thing that we'll do is, instead of having a source and target, we will actually have a velocity, both x and y components of velocity. So in here, maybe we want to actually set those. So we'll set the x velocity to some random amount. If we did something like -10 to 10, then sometimes what will happen is the one digit will fly straight up and then straight back down, which might not quite be the effect that we want. So let's say that we will so what we want to do is have this either be something like -5 to -10 or 5 to 10. And we can do that by, can we do that without an if statement? With this absolute value function, I don't think that's actually going to help, so we might actually need an if statement. If you're watching this later and have a better idea to be able to do this without the if statement, definitely leave a comment. So if, we'll say if this thing is greater than, this guy here is greater than 0. That's not quite half-half, but It's close enough that nobody could possibly tell. So if it's greater than 0, then we'll set the velocity to some positive random value. And then if it is less than 0, then we'll set it to some negative random value like that. And then we'll also set the y velocity, which we'll always want pointing up initially. Velocity y, we'll always want this pointing up, and we can also make that a little bit random. I'm just guessing here. We'll tweak that later. And then we can put all this stuff in here. So here, if we are having the gravity animation type, we will need a gravity variable, which I think we want global, because if we do more things with gravity, they should all have the same gravity, so it looks a little bit more realistic. We'll have to initialize that gravity to some negative amount. We can tune that later. And then every step will also have this change steps taken. That looks like it's actually common, so we'll put it after all of the animation types. And then in here, if animation type equals gravity, then we'll change x by some amount and change y by some amount. X will change by the x velocity, and y will change by the y velocity, and we'll also want to alter the y velocity by whatever gravity is, and we want that to be negative, which it is, so that it speeds up toward the bottom of the screen. Let's get rid of these debugging variables and give that a shot. Right now, this is creating only a linear clone. So what we can do instead is also create a gravity clone, and I can't remember what the parameters were. They're source x, source y, and a number of steps. So we'll say source x is the same thing. You can see that's here. Let's actually put this in the middle for now on the screen. Oh, we haven't actually used source x or source y anywhere, have we? So if we're at the beginning, so what's the beginning? The beginning is that steps taken is 0. So there's actually some common parts of code here. So we can do what's called refactoring this. We can extract a function. So this will be like create clone, create, I'll call it underscore create private create clone, something like that. And this will be all of the common pieces of code that we have. Let's stop that. The common pieces of code that we have between these two functions here. So this stuff is all common. And then animation type is common. Animation type like that. So we'll say create clone linear and create clone gravity. So we don't need those blocks anymore. And then the steps taken and steps total looks like it's always the same so far, so we'll say steps total, and then here we can say num steps, and here we can say num steps, and we can stick this in. Steps taken is 0, so we don't need this anymore. Don't need this anymore. I'm imagining that source X and source Y will tend to be the same, so we can add those as well. Source X and source Y, source Y, like that. And even though these look the same, they're actually not the same, I'm guessing. I'm not sure actually if that's how it works, but we'll place them just in case. And then here this needs to be source X and source Y. And similarly, over here, this needs to also be source X and source Y, and then we don't need this anymore. So the benefit of doing things that way is that now only the code that's specific to the linear clone and the gravity clone are copied more than once, and all the code that's common to them is only copied once. So let's start this back up and make sure everything didn't break, which it looks like it did. Gravity clone. Num steps, source X and source Y, steps total, source X and source Y, steps taken is 0. So is this running? That's running. This is also running. Oh. Let us see. Oh, we forgot to set animation type in here. So what's happening is in here, animation type is not linear and it's not gravity. So this part of the if statement's running, which is doing nothing. So set animation type to this, and that looks much better. Now, previously, the problem with this was that this is not respecting the fact that we're saying to start at 0, 0 over here. And that's because here we're never actually using source X and source Y. So when we first start out, steps taken is now we know it's always 0 because it's set here in this common function. So we can say if steps, so say here, if steps taken is 0, steps taken is 0, then go to I guess for the first step we won't actually want to move it yet. Or will we? Maybe we will. I guess what I'm not sure is if this should be in an else block or not. So say if steps, we'll try it like this. If steps is 0, then we will go to source X and source Y. Whoa. Source X and source Y. And so that's going, oh, except that does only need to be the case for gravity. So I'm not sure if these things actually should be in an else statement. So here, we'll put that in. That was amusing because there's a whole bunch of clones that had built up. It's actually kind of hard for me to see what's going on with the linear clones there. And that's actually that's not quite what I wanted. I want these to be flying up a little bit higher. So here in velocity y, let's increase these. Let's say 18 to 20. Maybe like 30 to 40. That's too wide of a range. 30 to 35. Alright, I think we're running into an issue now where all of these clones are probably still on the screen and just sitting down here. At some point, as the other clones, these clones were deleted. So steps taken equals steps total. There's steps taken. Are we not setting the total number of steps for gravity? Oh, we probably weren't even setting them in here. That's the problem. So this, let's say that we do 10 steps or something like that. That's not enough because they're not falling all the way back down to where they were. That looks pretty good. I actually think here might be a good spot to change the size. So we'll change the size to in the gravity by, that kind of looks neat. And then we can also fade them out. So let's change the ghost effect. That's too fast. That's still too fast. That may still be too fast. Now let's slow it down so that we can see them individually. Some of them are going too high for what I want. Let's first of all move this down a bit. So this is y, let's say minus 40, or minus 80, minus 100, and then let's move this over to 30 or something like that. Alright, the y values, the range is a little bit wider than I wanted, oddly, because it's pretty tight already. Let's do 32 maybe. And then let's make this a little bit narrower too. And then I'm curious if this is going to make it look more or less, more or less interesting. We can randomize this a little bit. I guess it probably doesn't matter that much since over time this will average out to 10. Maybe if we had a higher range. I can't really tell the difference. And then I think it would be good to have some kind of sound effect when this happens. I'm not sure if there's anything. I'm not actually that familiar with all of the sounds. This is funny. I wonder if I can speed this up. Wasn't quite what I wanted. I'm looking for something that sounds like it's saying, "Ow." It reminds me of a game I used to play. Oh! This sounds like it. Alright, that'll probably become annoying. But it'll do for now. So, here in the code, when we're doing this gravity effect, then we'll play that sound here at the beginning. Yeah. That is pretty unpleasant. Let's try that. This will be the section cope. That sounds pretty good. For some reason, it doesn't feel like the timing is right. I guess it's okay. Does this still work? I forgot to turn my frames per second timer on. Oh, it's still pretty high. So here, let's check if this thing can go much faster. Looks like it. That really hurts our performance quite a bit, but I don't think it'll be this frequent most of the time when someone's playing with it. Might have to optimize this a bit. I'm curious if this actually looks better now that we played with it. If we move this into an if else like I mentioned earlier, so I'm going to try that. If steps taken is 0, then do this stuff. Otherwise, we'll start doing these other things. And then this is no longer needed. That does actually feel better to me. You can see that the first frame always displays now. It seems like it's actually biased towards the left side to me. Oh, I bet that this random number is not actually picking any possible fractional number. It's probably only picking whole numbers, and so if it's 1, this will be true and it'll go to the right. Otherwise, if it's 0 or -1, it's false and it'll go to the left. So I guess we'll need to change this to pick random 1 to 2 is greater than 1. That does seem more even. You can be defensive about it and do a 1.5. That way it'll work either way. That actually seems pretty good. So here, I remember that our buttons up and down we're adding to this list called deltas. So we can show that again temporarily. It's empty. And then this deltas counter, let's get rid of this debugging code like that. Deltas is going to be deltas is going to be consumed here. If length of deltas is greater than 0, then we want to pull one of them. Is this still used? Just see if it's obviously anywhere. Oh yeah, it's over here. What did we set that to? X 11. So let's get rid of that and just replace this with an 11 so that we can remember what that speed was. Does it show up anywhere else? I don't see it. Let me get rid of this. So if length of deltas is greater than 0, then we're going to pull one of them off. So we'll say current delta and we'll say set current delta to set current delta to the first item of our list, and then we'll also delete the first item of the list like that. This way our deltas list is acting like a queue. Try this. Alright, and then current delta should now be -1. Indeed, that's what it is. So if, what I want to do is if current delta is -1, if current delta, let's say if it's less than 0, current delta is less than 0, then we want to do this gravity clone effect. Alright, this seems promising. So this is all going to be in here because we only want the one original hidden copy of the sprite to be doing this, not all of the clones. Hopefully, let's see. That's pretty good. Unfortunately, we don't, if we want the 1 to be flying out of all 3 of the numbers, we don't actually want to be playing the sound for all 3 of them. So what I'll do is move this block out of here where there'll be 1 for each of 3 clones, and we'll put it in here. That still sounds the same to my ears. Then what we can do is do 3 of these. Alright, now each time we click this, 3 of these number 1s are flying off. And we'll want one of them to be coming out of the decimal. So that will be the X position of decimal. I don't know how quick these blue sensing blocks are for finding the position of a sprite. They maybe actually be slow. Let's actually get rid of this deltas display. It's in the way of seeing what's going on. Make this full screen. So we'll want this to eventually be coming off of the right hand side of each of the numbers, not where the hidden original copy is. So we'll have to fix that later. But this will work for now. Go back in here and do the same thing 4 more times. This will be the x position of binary and the y position of binary, the x position of hex and the y position of hex. And we can try this out. Decimal's working, but the others do not seem to be. X, oh, that says X, and it should say Y. There, let's try that. Ooh, because that's not working at all. I think I forgot to hit this. Kind of fun. So now when we do a minus, we'll want to we'll not want to go below 0 because that's a whole nother topic, which is not the goal to explain here. So here we'll say if current delta is less than 0, and we'll also want if the value here is greater than 0, then we do all these things. If it is equal to 0, we don't want to subtract. So we'll do these things. And one of the other things we'll need to do is change the value by -1. So let's see how that looks. That's kind of fun. There should be some kind of feedback when you keep trying to go negative. Just to let you know that you clicked. So current delta here in the consumer is being shown. I don't really need to see that anymore. But we should have some kind of sound. We could try this. We don't want the whole thing though. Is there a way to cut this? Oh, there we go. I probably needed to click this or something. Nope. So I'll do it here. Start sound. This is not a clock ticking anymore. It's just a single tick. Tick. Tick, tick, play sound, tick, not until done. Here we'll say if the value otherwise, oh, we need this to be an if else, if else. So else is going to be start the sound tick, if is going to be this stuff, and the condition is just going to be this guy. Oops. And this will go here. We don't need this anymore. That's good. I like that. Maybe we could do something where everything kind of shakes a little bit when that happens. How would we do that? I don't want to send an event because that is going to take us out of our game loop. So I think the only way that we have available is to, well, I could send an event that it listens to and then puts in a local variable. That might be a little bit clearer. So we'll say broadcast. We don't really need to wait because it can do that even if it's slightly later. That should still be fine. So broadcast, we'll say broadcast hit bounds, hit boundary, out of bounds. Then here in these guys, we could say when I receive out of bounds, we'll set a local variable. So the local variable will be shake myself, and it'll set shake myself to be, oops, shake myself to be 1, and I guess let's get this all debugged first. So we'll shake myself to 1, and then we'll make a custom function that says maybe shake, and this will check if shake myself is 1. If shake myself is equal to 1, then if shake myself is equal to 1, then we'll set it back to 0, and we will we'll actually need to do this for several draw cycles, so we could call this shake myself 4. Yeah, we'll do something like that. So we'll set this to some number. I'm just guessing 6. Then if shake myself is, no, we need it if it's greater than 0. If it's greater than 0, let's have a few cases. So we'll say if it is greater than 0, then we will look at whether it's odd or even. Let's say if so this will be either 0 or 1, and we can turn that into an angle by multiplying it by some amount. Let's try 30. So this will be either 0 or 30 now. And then we'll subtract 15. Subtract 15, and that will take us to minus 15 to plus 15. And then we can set the direction to 90 plus this. 90 plus this. So we 90 plus 15 or 90 minus 15. Set, where's the, here, pointed direction, 90 plus this random number. And that's if shake myself is greater than 0. If it's equal to 0, then let's switch back to 90. And then if it is if else, if shake myself is equal to 0, then reset the direction. And then otherwise, we're not going to do anything. And then we also need to subtract 1 from it each time. So change shake myself by minus 1. And we'll do that here. And we'll do it here. Now if we maybe shake, let's shake myself to 10 as we click this. That may have been too much, so let's try 20 and 10. Alright, that is definitely enough to test this out. So here in draw, we are going to possibly shake ourselves. Let's do it after we move. So that will get triggered when this happens. That's longer than I wanted. Let's try 4. How does that look when the number is larger? Oh, interesting. All the numbers shake. That kind of makes sense. So let me get down to 0. Hey, that's kind of cool. So maybe we could also move it around a little bit. So we'll say go to, move it left and right by 1 or something. Change x by 1. I want to change it by shake myself mod to 0 to 1, and I want actually minus 1 to 1. So we'll multiply that by 2. So now this value is either minus, no, this number is either 0 or 2, and then we'll subtract 1. Oops. Subtract 1 from this, minus 1, and that will be what we can change x by. Let's see if that looks interesting. We can try times 4 minus 2. I couldn't even see it. Times 6 minus 3. Ah, that's kind of cute. Oh yeah, see, there's the race condition. Is that a race condition, or is it just moving each time? It may just be moving each time. This may just be a little bit more hassle than it's worth. Yeah, because if this gets run again before Shake Myself has resolved itself all the way down to 0, that's totally smooth. So 190. This one is at, or sorry, 9076, 9020, and then so 20 and 76 is 56, so we want minus 20 plus 56, so 30, it used to be at 36. 96 and minus 90. Let's actually put that in Initialize. We'll go to minus 90 and 36, and then this one will go to minus 90 minus 20, and then this one will go to minus 90 and minus 76. So normally it restores itself back to its original spot because it's even number of moves. But if you click it multiple times, what happens is before it's gotten all the way back down to 0, this gets reset back up to 4. So one thing that we could do, what could we do? We could know that this is where it belongs. So we could sort of have a X and a Y position. X and a Y position. And we could set those to 90 and 36. Set those to minus 90 and 36. And then here we could just go to X and Y. And then here, when shake myself, I'll reset it back here, like that. You can still see it drifting though. I guess what we need to do is here set like a num shakes. So this is going to just be 4. We'll set that to 4 over here. And then here, we'll use that and we'll say if specifically the shake myself amount is exactly equal to num shakes, then we can also, at that point reset that stuff first. There we go. Make a bigger number to test it out. That seems pretty good. So let's hide all of these debugging variables. And then I think that now we should be able to take this code and copy it into binary and into hex, and this one as well, binary and hex. And then we'll need to let's copy this code in binary and hex, like that. This will need to go in initialize, so we have to move out of the way. Let's make this smaller so that we can see what we're doing. And then here it's going to be minus 90 and minus 20. Like that. And then for hex, this will do the same thing. This will go in initialize. This will go this will be minus 90 and minus 76. And hopefully, if that's all working, we should be able to broadcast this out of bounds event. Oh, there. So it's working for decimal. Oh, we forgot to call. I know what. We forgot to call our new function. As in decimal, we called it here at the bottom, maybe shake. We did not remember to add it here or here. And I'm thinking it would have been nice if decimal, binary, and hex were all actually clones instead of original sprites. We didn't have to keep editing all three of them the same way. The only thing that's really different is this piece of code over here, so they could have shared a lot of code. But that's okay. We'll try this again. I dragged a here. Broadcast out of bounds. Alright. They're shaking around. That's some good feedback for when they get down to 0. We can make that bigger. Alright, then for the up arrow, when the up arrow is clicked, we'll add a 1 to deltas, so that's handled in the consumer. This code got rather long. Let's move these up because they're being called by this function. So oftentimes in code you'll have the lower level functions higher up and the higher level functions further down, so that as you're reading through you can understand what the lower level things do before you read the code that calls them. So back in here, we have this case, which is for a negative number. This is saying like processing a negative change. And so the else case for this is over here. Here's where we're going to handle adding a number. So I don't necessarily think that there's a maximum value, although maybe there will be. I guess we could test that out and set value to some crazy high number, like that. See what it looks like. Oh yeah, that doesn't even fit for the binary. What does fit? That fits 32,000. This is 2 to the 16, 20, maybe like 2 to the 24. I do not know what that is offhand. One 16777 16777 No, let's do to the 23. 8388608. That doesn't even fit. Maybe one digit less will fit. Nope. 2 to the 22. 419 4304. 2 to the 20. 104 8576. I thought these would fit. There we go. So we could go up to 2 to the 21 minus 1, 209,715. That's a little cramped. Alright, so this will be the max. We'll make a variable for it. We'll say max value. And we'll set that to over here. Set max value. Set max value to go. This. Set max value to that number. So you can have something similar if value is greater than or less than max value, then we'll so we'll say if value is less than max value, like so. Oops, this is so hard to drag. And then we'll do stuff. Well, we can do this for now. It won't be correct, but it'll at least check to see if the value is changing. So we'll change value by 1. Otherwise, we'll say out of bounds. So we're out of bounds right now. And that's working. Yeah, that's... No, that's not working actually. So what's the value? 2097122. 2097151. If value is less than max value, $2097115. I'm a little confused. $2097151. 2097152. Wait a second. 2097152. Yeah, that's too big. 151. Okay, there we go. We should hide this when we start, by the way. Over here. Now it might make sense to have this bigger. So you can play with any of these numbers. Is that 168.52? We should set this up in the initializer. When we receive initialize, then go to Let's call it 170 and 50. And then for this guy, let's just copy that over. For this guy, the down arrow, when I receive initialize, we'll go to 170 and 7 minus 70. 170 like that. Maybe a little bit lower. Maybe 90. Minus 90. Not sure where my clones went. Oh, I hid this thing, but then it didn't show it. So here, when we create a clone, this one's actually the higher level function, and that one's the lower level. When we create a clone, we need to show there. Something like that. Or maybe we should show here. Show here. Show. And then for gravity, there's blue and purple blocks here anyway, so there we go. This is looking good for the down arrow. Numbers coming out. But for the up arrow, we'd actually prefer if they're moving from let's say from the up arrow. So we'll say create linear clone and this is going source, target, num steps, and we had before about 11 steps. So source is going to be the position of the plus button. We'll say source is the plus button is +1, x position of +1, and then y position of +1. The target will be decimal, and then earlier we experimented and that was 11. So we don't need this one anymore. Let's see if that works. And we'll do something similar for the other ones. Duplicate and duplicate again. this will go here, and this will go here. We can just switch this to hex, because now we have some extra code blocks underneath this big stack somewhere. Don't need that anymore. And we don't need that anymore either. Hex, this one has to be hex. Let's see how that looks. I don't actually think this is helping any. So the thing that looks odd about this is that we want the number to increase as the one hits it, not the other way around. So So what we really want to have happen is if we're deleting the clone and the animation is linear, then it's at this point, where we would actually add 1 to the value. Let's try that. Okay, so the issue is there's 3 of the clones and each of them's adding 1. So we want the original copy to be controlling the addition, but only the clones know how many steps were taken. We could do something messy with a list where each element in the list would have, how to work. Each element in the list would keep track of how many let's say you launched 3 clones, there'd be 3 items in the list. Each element of the list would keep track of how many steps each of the 3 clones was taking. So the first element would be the first clone, the second element would be the second clone, and the third element would be the third clone. And then each time through in the original sprite, we would add 1 to each of those elements, and then when it hit steps total, then we would do the add there. It's a lot of list operations for what we want. Another thing that we could do is have each time through this draw function we increment a number. Theoretically that's a little bit undesirable because that number will keep going up forever, and so there's some point, if someone were to run this project for a really long time, where that might run out. So I'm trying to think if there's anything more efficient that can be done. I will do the list idea. The number of clones in flight should never be that big, so the list shouldn't ever be that long. So this is going to be the queue of additions. Queue of value changes, or queue of steps until pending steps until pending adds. So when, rather than changing the value here, what we'll do is we'll add 11. We'll say like linear, let's do another constant. We'll say like default linear steps. And we'll set that to 11 and initialize over here 11. And that way we can replace all of these guys with this variable constant, and if we change it later we don't need to go back and remember all these different spots where that code was. So we'll say add 0. Add default linear steps to deltas. Let's try that. Whoops. That's not working. Problem is this one, possibly? What did I change? That's why. Right now, each time through the loop here, and basically this doesn't matter if the length of delta is 0 or not. So we'll say if, the function's getting really long. Let's make this into a function. So we'll say if steps until pending adds, if the length, so what is this going to do? It's going to subtract 1 from all, so let's call it like update pending adds, run without screen refresh. We'll update pending adds, and this will say if the length of pending adds is greater than 0, then we'll subtract 1 from each of them. So we'll say repeat until, make a loop iterator, it's often called I. We'll set I is equal to 0, or we'll set I equals 1, and then we'll repeat until I is greater than the length. Actually, we can set I to the length at first, and then subtract, and then repeat until I is less than 1. Less than 1. I is less than 1. And then we will subtract 1 from item I. Item I of steps. We'll replace item I of steps with this minus 1. This minus 1. Like that. And this code can go in here. So when we update pending adds, we'll go through and subtract 1 for each one. Now these steps are saying they start out at 0, and then each time through the loop we're adding 1, and if it's equal, we don't really need this anymore. Oh, I do need to delete this clone. If it's equal to I think that's 11 steps, so it starts out as 0. And then it'll move, and then it'll add 1. So by the time it says 1, it will have moved 1 time. So once it's 10, it'll have moved 10 times, and then on 11, it will not move. So when this gets down to one, it will have moved 10 times, and then when it becomes 0, that's when we're deleting, and that's when we'll add 1 to the main global value. So we'll say, we'll replace it, and then if, we'll say if this value that we're looking at is now 0, then we will delete it. And we will finally, not sure if I still have the block for that, looks like not. And then we will finally add 1 to the value here. So let's try that out. This isn't getting called. So update pending adds, we'll do that. We don't want to do it for the, we do only want to do that for the original. And it doesn't matter if delta is empty, we still want to do it anyway. So I'll say update pending adds there. And let's make sure we clear out this thing. Let's see, delete all of steps. That's still not working. So update pending adds is, I think, getting called. There it is. Copy that in there. We'll say updating. Oops. Updating like that. And I think we need to set this guy. Alright, it's being called. But this is not being subtracted. So length of pending adds is greater than 0. Let's check that out. Oh, I here. So we're setting I, but then I is never actually changing, so this loop's not making any progress. So we need to change I after this. notice at the very last thing, let me hit stop, this is very slow. So at the very last step in here, we need to change I by -1, because we're going through this list backwards. We're starting with I being the length, and we're going all the way back down to 1. And then when I becomes less than 1, then we drop back out of the loop. So let's try that again. And it is still not updating. Let's clear the log. Delete all of I notice updating is not being called here. I don't know where those 10s were coming from. Let's try this. Here. Alright, let's try that again. Okay, hello is being called. The length did go down to 0. There we go. So you can see these are counting down. It's a little bit inefficient, I think, but this program's not going to be doing too much else, so I don't think we need to worry about it in practice. Let's hide these debugging variables again. Deltas, steps, max value, default, and then the value itself. Maybe we can have a different sound for up than we have for down. That sounds pretty neat. here, instead of this sound, we'll try that. And then make sure the zeros still work. It's looking much better. So one other thing that I want to do is to have the numbers coming out of the least significant digit, since that's really the thing that's changing. Although this is kind of fun to play with already. So to do that, we need to figure out what the length is of each of these things. And so I don't need that anymore. Here, the decimal length is going to be I really want to share code with this guy. I don't want to put it in a list, because that would prevent ever having more than one of these decimal sprites on the screen at the same time. This may just be one of those situations where Scratch is a little bit limiting. I guess we can just calculate it out here. So we'll need, I guess, calculate decimal length. And it'll put it in a result. Let's put it in like a result. So this function is going to take the length of this decimal number. Let's actually call it decimal. Or calculate length in decimal of the decimal number, and then there'll be a calculate length in of binary, and this will still be the decimal number. And then finally there will be a calculate length of hexadecimal, and it'll take a decimal number. So all of these are going to set result to something. And the easiest thing to do would be to copy and paste the code. So for the decimal number, we can just actually use the built-in length function over here. So I'll set the result the result to the length of decimal. For hexadecimal, we will take effectively this code. And I don't want to copy the draw function name. Copy that into, actually we don't need all of this, so it's just this part, temp, value, and then we add some stuff to value. So we'll do all of this. Do all of this, and then the length of value will be the result. Length of value. And then for binary, it'll be the same thing. Take this code and copy it into here. And this won't be value, it'll be this input parameter. And at the end, we will set result, like so. So now, in here, well, now that we have these helper functions, we can calculate the length in decimal of the value, and then we'll want to set the position to the target position. Oh, this isn't where we want to do it. We actually care about it over here. So we'll calculate the length in decimal, and then we'll add that to the target x position. What's going on? Alright, we'll add that. We'll add that times result, say result times the width, which unfortunately is stored in here. I know right now that they are all the same globally, so maybe instead of having separate we'll have to have some more global variables, unfortunately. Character with decimal, character with binary, and character with hexadecimal. And then we're going to see where that's used here. So instead of this, we'll use character length decimal. It's kind of unfortunate. And then instead of this, Ugh, yuck. Then here we can do result times character with decimal plus the X position. So similarly with binary, so set character with binary, and this will be binary, and then I think that makes this unused. Don't see it anywhere, so we can get rid of it. And the same with hexadecimal. Set character with hex, and then down here again, use that. Just created some more garbage block. And then this should be unused. Here, we can do the same thing. We'll calculate the width in decimal, and then in binary, and then in hex, like so. And then in all the cases, we'll have this will be for binary, result times binary plus the X position. And then same thing for hex, result times hex plus the X position. And if everything works, much better. Let's hide these debugging variables again. Delta's consumer result, and these character widths. And then actually the same thing needs to happen for the gravity clone. I was wrong about that earlier. So this let's copy this whole block. So we'll pull out these expressions because we need them. Hex, binary, and decimal. And then we don't need these, but we do need these. So calculate the hex here and the this guy needs to go replace that whole thing. Sometimes it's really hard to use the mouse. There, and there. Now we have more junk underneath here. let's give it a shot. That is a little bit cluttered looking to my eye. So I'm going to have them fade out a little bit faster. Which is here. Let's try 5 more. Well, I'm pretty happy with that. Maybe one other thing we can do is switch the colors of these arrows. I'm just looking up the colors of my logo. So this will be going from I'm just looking up a hex to RGB converter, which is kind of ironic. I could probably actually use this. This is useful as a toy, but definitely not as a hex calculator. So hex 17 is decimal 23. So if I wanted to change the fill of this color, does this not have a RGB? Oh, I guess I'll need to pick. I'm not actually sure how to do this. Hold on for a second. I'm going to pause the screencast temporarily. Okay, I'm back. I just wanted to import this so that I could just use the eyedropper tool. It'd be faster than figuring all of this out. So I think I can eyedropper anywhere on the screen. We'll find out shortly. This will be... Nope, doesn't look like it. But what I probably can do is copy this into here and also into here, and then copy and paste this like so, and then I should be able to use the eyedropper on this guy. That's a very darker blue, so let me swap it with this one. And I guess we'll also do that one, but we'll lighten it up. Maybe something like that. And we'll do the same thing here. Lighten that up too. And then for this guy, I didn't know this is a gradient. It doesn't look like one. We'll pick this color. Yeah, it certainly doesn't look like a gradient to me. And set the outline to black, possibly. Yeah, something like that. And then let's actually copy that into the minus costume. Get rid of, well, move these to the back, get rid of these, and then use this one to pick the colors here. This will be 20. I guess for the backdrop, I can do the same thing. Maybe paste this in, and then this is 5584, 55, 84, 55. And this is actually a trick I learned recently, where you can actually change the size of the square to be quite large. And then we should be able to switch these as well. This color is 127290. So we could change These fonts doing the same thing. 12, 72. It may be faster to copy and paste this in here so that we can eyedropper that. And we'll copy it in here. And we will copy it in here too. For these numbers, I remember setting the color so that we could use some of these effects. So we could do the color effect, change color effect. Maybe a white would look good. Change brightness. Maybe we'll use the same yellow. Oh, but we have a lot of these costumes. I wonder if the colors are the same. 12, 72, 90. So if we set color effect to 12, will that turn it yellow? Kind of is. Set brightness to maybe 75, 50. We can have something like that. We should put those in variables. So we'll have font, brightness, and font color. And then we can actually use these to play around with them. So for now, we'll actually want to put them in the draw. In addition to in Initialize, and then we'll get rid of them from draw later. could go for a green. $33.67. Let's copy that into here, and into here, and into here. Like so. And here. And here. It seems kind of silly to make this value slider not a power of 2. So we'll change it to 2 to the 16th. Or that's not what I was thinking of. 2 to the 14th. 16,384. Maybe 383. There. Oh, maybe we'll do 2 to the 16th, 65,535. That gives us 2 bytes worth. I guess the issue with that is really hard to control. Maybe we should actually just do 1 byte. Alright, I think I'll stop here for now. Let's turn this off so that we can share the project. We'll call this a hexadecimal binary decimal toy. Thanks for watching. If you're watching this later and thought that this was interesting, please subscribe to the channel and press the thumbs up button. Leave me a comment if there's anything that you would like to see in a future video, or any commentary that you have on this one. And thank you for watching, and I'll see you next time.